Hello, I'm Dan Alford with Arc Specialties. Welcome to Dan's Cadre of Experts. We have a special guest today, somebody that I go way back with, Dick Holdren.
Thanks for inviting me.
Well, love to have you. This morning, you and I were talking about our history. We can't even figure out when we met because way back in the early 80s, I was building jackup rigs with Jeff Post and Joe Barker, and somehow or another you were involved in that. We might have met at that point.
Yeah, I can't remember that we actually met. I knew you through Joe, primarily through Joe, but Jeff as well. And so once I finally did meet you, whenever that was, I felt like I knew you.
We've been working together on and off for quite a while, and you've been full-time at Arc Specialties for over 10 years because you got a Rolex. I don't see you wearing it today, but you've been with us for quite a while now.
I started in 2012.
2012.
Yeah.
It's been a great ride.
Yeah.
So, way back at the Savad days when we were building jackup rigs, we were building jackup rigs out of the same material they make submarines, which is hard to weld. And I learned so much from Jeff and Joe, and those are fellow Ohio State welding engineers.
They are.
Just like yourself.
Yep.
That's how you started, right?
Right. Yeah, I went to Ohio State. I grew up on a farm in southeastern Ohio. My father was an apple grower, and I had an affinity for mechanical things, and when you live on a farm, when things break, you fix them. And so I had time working, taking things apart, putting them back together, and so I figured engineering was in my calling. And I went to Ohio State because living in the state of Ohio, that's the cheapest place I could go, and they had a wide variety of engineering curricula. So I went there, and at that time, if you claimed an interest, they put you in what was called university college for your first year. So I was in the engineering university college, and one day a week we would meet, and they would bring the chairs of the different departments in to talk about their programs. And up until that point, I had never even heard of welding engineering. I figured, it was at the bottom of the list alphabetically, and probably by reason as well. So, but the chairman of that department came in, Professor Roy B. McCauley, and Roy had this gift of he was such a promoter. But he described the program, and I followed him back to his office that day and made an appointment, went in there the next day, and called my parents that night. I said, I found what I wanted. And I think probably years later, they finally admitted to me, we really questioned why we were sending you to college to learn how to weld. But it's been the greatest ride, and I really think that the welding engineering program at Ohio State is still the only ABET accredited welding engineering program in the country. There are quite a few other welding engineering technology programs, but the Ohio State welding engineering is really the first and still the only one. And so I've never looked back. It's just been a great ride. The professors I had in school most of them had come from industry, and
That's what you want.
Yep. So they taught things on a very practical level. One of my professors, Dr. Robert C. McMaster, is probably considered to be the father of NDT in this country.
Non-destructive testing.
Non-destructive testing, and since nobody trusts welds, non-destructive testing is really important, and it's really important that I had that cross technical background, because I've used that through the years, being able to both specify how to do the welding, but also knowing what the requirements for those welds are, and whether or not they're being examined or tested correctly. So I still carry my level 3s in mag particle, penetrant, and ultrasonic testing, and then I've got a number of welding credentials to go along with it. But the combination has been really good. One of my other professors was Clarence E. Jackson, and Clarence, I call Clarence the father of sub-arc. He was a formulator for Union Carbide, Linde Union Carbide back in, probably back in the 40s or 50s.
Which turned to LTEC, which turned to ESOB.
Right.
So they're still around. And
yeah, and some of the fluxes he formulated are still being produced by ESOB. Not a whole lot of them, because most of his fluxes were fused fluxes. But, just having that kind of background has been so helpful. The other thing that was required of us was that we were required to have at least 2 summers of experience in the field, and they would help us find jobs. And I worked 1 summer for a pipe fabrication shop, Draveau Corporation, in Marietta, Ohio, and then I actually worked two other summers at Chicago Bridge and Iron Nuclear in Memphis, Tennessee.
I thought that was required for Ohio State guys. Everybody had to work for Chicago Bridge and Iron.
Not actually required, but it was encouraged.
Pretty close.
Yeah, and that shop in Memphis was just a wild place, because they were gearing up to where they could build 6 nuclear containment vessels in a year. They had a 500-ton bay and a 300-ton bay.
What year was this?
This would be 71.
Gotcha. Okay.
It'd be 72 and 73.
When nukes were cool back then. They're cool again now.
Yeah, once they got up and running, 3 Mile Island hit, so that it's now a Navy propulsion lab. But they, they knew how to do it right, and they, like I say, they were geared up to where they could produce. It was a production line.
I got to go back. Okay, got to rewind a little bit, because I've had the honor of going to your family homestead, where you're still living now, right?
Yep.
And tell us the story about that shoe that was on the wall, and your dad's prior career of pole vaulting, and who he was hanging around with, and who beat him to the Olympics.
Yeah, my dad was a pole vaulter, and it was interesting that back in that day, pole vaulting was something they did as kind of a game, and he started pole vaulting before he was even in high school.
Just for fun.
Just for fun, and back in that time, they used bamboo poles.
Sounds scary.
Yes, and they actually rated the poles they had them rated by weight, but my dad would use one that was 10 pounds lighter than his weight. And I saw some stop-action photos of him jumping, and he actually got a pretty good bend in that pole.
I suspect.
And but when Dad was a freshman at Ohio State, and he was actually on a track scholarship, he won the state high school championship for his high school, I think, 2 years, and he was the only competitor. So he was the sole member on the team, and they won the state championship. But his goal was to jump a foot higher every year, and he still has the record at his high school, but he didn't. I think it was like 12.6, so he went to Ohio State on a track scholarship. And as a freshman, his teammate was Jesse Owens.
Heard that name.
Yeah. And Jesse and Dad and 2 other fellows from Ohio State went to the Randall's Island, New York, to the Olympic tryouts. And 2 of the 4 made it to the Olympics. And Dad missed going by a quarter of an inch.
Darn it.
Yeah. And then the following year, when he and Jesse had become close friends, and when Jesse came back from the Olympics, he he knew Dad was into long jumping, or what they called it broad jumping back then, and so he gave Dad his rake takeoff shoe that he wanted the Olympics, and that's the shoe that.
Okay, I knew there was a story behind that.
That you saw, and so he gave it to Dad because he wanted Dad to be a long jumper like he was. So, but unfortunately, that next year, back in those days, they actually dug a pit and put sawdust in it for a landing area. So landing was really part of the jump, where today high jumpers and pole vaulters don't care whether they land on their head or how they land because they've got so much cushioning. Well, back then you had to land on your feet.
You didn't have to.
Yeah.
Well advised, though.
Yeah, but in his first meet that following year, all of the other competitors were out before he made his first jump, and on that first jump he went out of control and landed outside the pit on his shoulder.
Ouch.
So,
did he clear the bar?
I don't think so. I never
Darn.
heard that part of it.
I just think that's a great story. You know, you tell me about the farm, and I did find it ironic as I walked around the old apple farm, and y'all had techniques for crushing the apples to make cider and everything else, because you know you had to store them somehow or another. Everything was made of wood, so it is ironic that you now are living in a world of metal.
Yep. Yeah, it is. That. And most of the wood was oak. My dad and my grandfather liked to build everything out of oak. So I don't care if it was sheeting on a building, it was oak.
Mm-hmm.
And so it's but that's just the way they did things back then.
One other personal aside I wanted to get into is motor scooters, because that is kind of how we got together, right? Because we're dirt bike riders.
Yeah, and again, the connection there is Joe Barker.
Joe Barker, who is the youngest guy to ever win a gold medal in international six-day trials in the history of man.
Yeah.
And he was your protege, and he was my boss.
Yeah, and I heard about Joe grew up in Belpre, which is about 10 miles from where I grew up. I never knew him in school. He also was a pole vaulter.
Oh, I didn't know that.
In high school, yeah. And but a mutual friend of ours said, you know, there's a kid starting at Ohio State that rode motorcycles, and he's from Belpre, and he thought he was going to be going into engineering. He wasn't sure. So I would read about Joe in the motorcycle magazines.
Because he was a phenomenon.
Oh, he was. He was just an up-and-coming star. And so one day I was riding my bicycle down High Street and noticed this guy walking down the sidewalk with a U.S. team helmet.
Not a lot of people have a U.S. team helmet.
So I followed him over to a off-campus garage. He put up the door, and there was a Penton sitting there. I thought,
that's a motorcycle.
Yeah.
Very fast motorcycle.
Yeah. Yeah, it's they're now called KTMs, but they were originally imported from Austria by John Penton. And so he put his name on it for years and years. But I talked to Joe and asked him, you know, I said, are you interested in engineering? And he said, yeah, I guess so. And at that time, as you said, he's the youngest person ever to get a gold medal at the International Six-Day Trials. And he told me later that within a couple of weeks after that, he became a freshman at Ohio State. And he said he went from the top of the world to the
bottom of the stack.
World. Yeah. And so I said, have you ever thought about welding engineering? And he said, never heard of it. And so I said, come on, let me show you around. So I took him on a tour and got him hooked. And to this day, he still, when he introduces me, he said, he's the one that got me into this. Yeah.
And we've all had great fun together. We've ridden motorcycles together. Joe actually ran my team when we raced Baja way back in the day. And Joe's quite successful with a pipeline welding company. He used to weld them inside out. He would send people inside the pipeline and weld the inside so you didn't have to dig around the pipe. clever guy. So that's the connection, is motorcycles, Joe Barker.
Yeah. And Joe got into that business, and everybody at that time was welding with stick electrode.
Right.
And Joe introduced, that's when Palcon had these small inverter power sources.
Little bitty ones.
Yeah,
They'd scream like mad.
And he would use those and bit it with flux core, with Palcons, and would just eat people up with, I mean, it would just, production was, I mean, he would still bid it like it was a stick job, and he'd still get it, and then he just would, really excel. So it took him a while before they figured that out and started competing with him.
Well, it's funny. That's another connection we have. So back in '83, Joe got a contract to do a hot tap at a plutonium plant in Idaho, and Jeff Poston, another one of our friends, another Ohio State guy, was the guy that engineered it. I built the machine, and we had to do TIG welding. I had to build it so it was an orbital TIG and then a plasma cutting machine. And guess what? Palcon power supply could do both. And so,
Wow, I didn't know that.
yeah, and so that was how we kicked off Arc Specialties way back in the early '80s, was with a plutonium job. So it's been easy since then. It's the same crew of guys go over and over. All right, you've come a long way since then. So I think the one thing that's been constant in your career, even though you've worked on everything from defense to consumer stuff, is code committees.
Yeah.
Talk about that a little bit, because you got to tell the story about how you got into it.
Well, I was on my first code committee I started in 1978,
Yeah.
and which was that was the year I got my CWI as well.
Certified welding inspector.
Yeah, and I was I then started in the early 80s. I started teaching the CWI class for AWS, and the material we had was pretty dismal stuff. And so I got the contract to actually write the new text it's called Welding Inspection Technology. And that text, although it's been revised several times, is still being used by AWS.
That's your work.
Yeah. And but when I was teaching that, I always say the best way to learn something is to teach it.
Indeed.
And I was, a big part of the exam has to do with terminology and symbols. And when I was teaching, I was having issues with some terminology that was being used. I think it was inadequate penetration. And so I wrote a letter, and this was back in the days before computers when you actually wrote a letter. And
The kids call it snail mail, but go ahead.
Yeah. And so I wrote the letter to the committee saying, I see some issues, but I'd be willing to help if you would like my assistance. Well, I got an application in the return mail, and I filled it out, and I thought, what the heck did I get myself into?
Put up or shut up.
Yeah. So, but I just thought, definitions. That's that's got to be boring as can be. But that committee has been one of the most interesting committees that I've ever been on. I've been chair of the committee for almost 30 years, and it's A3.0 is the document, and we call it the Webster's of Welding, and it's become a passion, and it's when you have to look at definitions in terms of how they can be applied to the entire industry, and there's so many different processes and so many different applications, it does become a challenge, but there are cases where definitions can be legal or a basis for legal decisions. So I went from there, and I'm currently that's the A2 committee. I'm also on the B1 committee as methods of inspection. I'm on one of the B2 committees for measuring arc energy for welding processes. I'm on I'm on D11 or the D1 committee.
Structural welding code.
Yeah, the structural welding code, and I was also on the Technical Activities Committee, which is the committee where you have chairs of all of the different AWS standing committees that review every single document that AWS puts out. You get to review and comment. And I, for years, had made comments to D11 about certain things and would get readily ignored. And so one of my friends who was on the committee said, well, if you want to make some changes, get on the committee. I was an applicant for the committee for over 11 years. And
Weren't sure you're qualified.
Yeah. And finally got on a task group, and then, a few years ago, I actually got on the subcommittee for
Excellent.
D1.1. So,
which is
and I still can't get anything changed.
Yeah, you got to try though.
Yeah.
Let's talk about this for a second, because we just hired a new material science major, Abby, just started this week. And when I introduced her to you, what was my first thing? I said, Abby, if you want to join a code committee, you have your boss's support, and you got, because you need some youngsters on these committees, right?
Sure do.
So we're talking to you guys out there. If anybody has any interest in serving on these committees, there's places, right?
There are places for them, and one of the only good things that ever came out of COVID was it made us aware that we could have meetings virtually. So from that point forward, all of the AWS committees are hybrid, or all of our meetings are hybrid meetings, meaning that you can be in person or you can be online and still participate and still get things done. So, and we used it. We used it extensively on the Terms and Definitions Committee, because that was something that we could do very effectively remotely or face to face.
You'll learn a lot. You'll affect change, and it looks good on your resume.
Yeah, and one of the committees that I've more recently joined is the D14 committee. Is for they write specifications for specialty equipment. There used to be a D14-1 for industrial and mill cranes, a D14-3 for construction and ag equipment, and then D14 for classification of joints for this equipment. All of this equipment is loaded in fatigue. So the whole, and then this past year, they published the first edition of D14.0, which has combined all three of those previous codes into a single standard.
So they're all doomed to failure if they last long enough.
Yep. But one of the there are a couple of things that I think are so important about D14. The way they do it is, number one, they establish responsibilities in terms of whether you're part of the design authority, the manufacturing authority, or the inspection authority. And then they say, okay, for each of those authorities, here are your responsibilities, and then more importantly, here are the credentials for those individuals. The other thing I like is the fact that when a designer specifies a certain joint detail, depending on how that particular detail is expected to perform in fatigue, it's assigned an inspection class. Then, when you get back in the inspection part of the code, depending on that inspection class, it tells you exactly what type of inspection has to be performed, or if there's NDE required. And then finally, it has separate acceptance criteria for each of those.
Well, Jeff Post, our mutual friend, I heard him do a talk one time where he traced the origins of these codes and specs back to the boiler explosions in the late 1800s, and somebody had to do something about it. We could either have the government get involved, that's never good, or ASME created the system of voluntary codes and specs. This is how Jeff described it. And I did a paper on it in college, and I think he was right.
Yeah.
But so all these codes and specs that you're writing and everybody's writing, they're completely voluntary, right?
Yes.
So you don't have to adhere to them, but you might have trouble insuring or selling something that doesn't. I think it's a wonderful system that the world uses. Think of how much worse it would be if it was government.
Oh gosh, yes. Yeah. one of the scary things that we're facing as a society is there are some senators and representatives that have initiated what's called the Pro Codes Act.
Uh-oh, that
And-
sounds ominous.
Yeah, and what it would require is that if there is a code or a standard that is mandated by law, that code or standard has to be made available to the public free of charge.
Which is something that keeps these societies going, AWS included, selling these codes.
Yeah.
And it's not much money, but to you it is. I mean, to AWS, it's significant income.
Yeah, and they just, I mean, I made a visit to Capitol Hill back in March to promote. We were there with ASNT to promote workforce development and training and trades and so on. But I mentioned to several of the offices this thing about the Pro Codes Act, and they weren't even aware of it. And by the name, it
Sounds pretty good.
yeah, but and they just don't have a clue of how much. I mean, yes, it's all volunteers that are contributing to this, but AWS is responsible, or ASME, or whatever society is responsible for coordinating that and publishing the standards. So it came before the House a year or so ago and got defeated, but there's some senators that have it back up, and they're looking at it.
Mm.
So
Tell me if I need to put a call in. Do what I can. So you said you were in Washington. Working in what capacity? We haven't mentioned what your current job is in addition to working for Arc Specialties.
well, I'm fortunate to be president of American Welding Society.
Congratulations. You know, all the years I've known you, this has been sort of a goal of yours, hasn't it?
Yep.
So this is like a senior project, a capstone for you.
And it only took me 50 years to get here.
Well, yeah, that's the way it's supposed to be, though. You know, if you get the rewards too early. So I am absolutely delighted that there are people like you in the world that are willing to invest this much time and energy into a voluntary position that is so critical to industry.
Well, and I'm one of the very few AWS presidents who has gotten here through my codes and standards work.
Oh,
You know,
really?
serving on, I've served on technical committees, on education committees, and more recently on certification committees. So there have been a few that have preceded me in that by that capacity, but I'm one of the few more recently.
And that your term runs until January,
Till December 31st.
December 31st. Then you pass the gavel or whatever you do.
Yeah, yeah. So, but it's been a great year, and it's exciting to I get to go to schools, but I've really tried to concentrate a little bit more on going to manufacturing operations.
Good for you.
Supporting that. In fact, week before last, I was in Oak Ridge, Tennessee, visiting Dr. Adam Stevens, who
They're doing great things.
Oh, ARC is working with them to try to bring some practicality to the world of additive manufacturing, which is one of the biggest technological areas of interest in welding. I mean, most welders will say we've been doing additive manufacturing.
And they have been.
for years, but they're I think with ARC's involvement, they're doing some pretty revolutionary stuff.
Well, they're doing more than that too. You know, the first salt-cooled nuclear reactor built in the last 50 years is being constructed there. I am so impressed with Oak Ridge. It's been a pleasure working with their people.
Yeah.
A lot of smart folks.
I was telling Abby this morning, one of the things that Adam showed us was they are printing microstructures, and Adam showed us this one example of it looked like a coin, and what they had done, they had printed the image of the Mona Lisa by somehow altering the microstructure to make a
Yeah, I've
pattern.
seen that.
and then when you polish and etch it, you can see the image.
It's amazing.
Yeah. So, but and Adam is even sending some of his mechanical testing to welding consultants.
Yeah.
In Columbus.
Keep it in the family.
Yeah.
So this whole process of becoming president is a long, arduous path. It took you 50 years, but describe it in case somebody else might be interested in supporting one of these professional societies as you have.
Well, you get nominated as my path was I became a director at large, which is on the board, AWS board. There are district directors that represent all the 22 districts, and then there are 6 directors at large individuals who have served on as chairs of standing committees or some other path. So they kind of are there to serve at the wishes of the president to do special projects. And
These are all volunteers.
Yep. And I did that for 4 years, and after my election for my second term, I ran for vice president and got selected. And so you serve then 1 year as vice president elect, and then you serve 3 years as vice president, and then the fourth year you're president. And then there'll be 2 years after.
Not always, right? The path doesn't always lead to presidency.
Right. And then there are 2 years as past president where you're still a member of the board. So, but it's been a fun ride, and it's exciting times for, with the technologies that we've got, and one of the big areas that I'm more involved with now than I was earlier is in the area of certification, and I'm on what's called the exam bank committee, and we're the ones responsible for approving all the questions that go on all of the AWS certification exams. So, I mean, everybody is aware of the certified welding inspector program. That's the primary one, but we're working to develop new ones, and I served as the chair of the subcommittee for the certified welding engineer, and we rewrote the standard, or the certification's been available since the early 2000s, but we rewrote the standard, and I think have really beefed up the certification where it really is going to mean something, and it's designed for individuals that may have different backgrounds. For example, they might have if you have a college a degree in engineering, there is a path that you can take to become a certified welding engineer. And then if you're for example, if you're an IWE, International Welding Engineer, there's a path toward CW Eng. So that new exam will be on the street hopefully the first quarter of next year. So we'll be ready to. We've got beta exams going right now, but we hope to have that up and running. And I think it's going to be. And the whole thing about certification is it's a way of recognizing individuals for capabilities, and it's controlled in a way that it really does mean something. The IWE, for example, is a diploma, and there are no exams associated with it. You basically have to, you subject yourself to like 400 hours of training.
And you're in.
And you have a diploma. Most of the programs around the world are that way, but this is going to be a certification where there actually are exams that you have to take and have to pass.
Outstanding, because I believe in Texas they don't even have professional engineering license for welding engineers, do they? So although you have a PE in welding, it's not valid in Texas, correct?
Right.
So there's something wrong with that system.
Yeah. Well, the state of Ohio had its own professional engineer in welding back when I was in school, and but that went by the wayside, and so now if you want to become a PE, like here in Texas, if you want to become a PE, you can. There is a materials science.
Okay.
PE. There's also a mechanical engineering PE, but in the material science PE actually has some questions on welding, but it's not a welding PE. So.
Well, the system needs some revamp, is my point. So
Yeah, yeah,
keep up the good work.
yeah.
So tell us about Welding Consultants Inc.
Well, my partner in crime, Bill Svekrick, he
This
and
was 1978. Give us some time frame.
81.
81. Gotcha. Go ahead.
Yeah. When I was at Ohio State, I took another year of grad school, but wasn't. I enjoyed the partying that was associated with that additional year, but we had to write a thesis back then, and I just really couldn't get enthused about it. So I asked my advisor. I said, I need to get out of school so I can start to learn. And so he.
Is this Jackson?
No, this was Roy McCauley.
Okay.
Yeah, and so I got this job at a place called Materials Joining Consultants in Columbus, and went to work for them in '75. And Bill and I met there, and then in '81 we decided that we were going to split off and start our own deal.
Kind of arrogant, isn't it?
Oh yeah, yeah. And it was really funny because we got this accountant to work with us, and one of the most painful things was he said, "Okay, I want you to sit down and figure out where your money's going to come from, who you're going to work for,
That's important.
and how much are you going to be able to generate." Mm-hmm. And and gosh, it was a painful experience, but we went through it, and we were within 10% of the dollar amount, and we didn't work for any of the people we thought we would.
Best laid plans.
Yeah. So but it taught us that, and the hardest part about consulting, as you well know, is you get so doggone busy doing the work, you don't have time to go out looking for the next job.
That's why I like having a big company. It greatly simplifies that matter.
Yeah, yeah. But when you're just a handful of people, it makes it tough. So
here you are, an owner of a significant consulting company, and you live happily ever after.
No, things change. Yeah, I worked there until 1996, and I got approached by the Edison Welding Institute.
Yep, the biggest welding consulting group or welding research group in America.
Yep, and it was actually my advisor in graduate school was Dr. Carl Graff, and he was in the engineering mechanics department, and he was in ultrasonic welding. He was in ultrasonics.
I saw his foil stuff. It's very clever.
Yeah,
that's been commercialized.
Yep, yep, and he was the one that I forgot where I was going with this. But
so they talked you into quitting a company that you owned.
Right. Yeah.
Now, how does that work?
Well, they the payout wasn't very good.
Oh, I see.
But they were EWI was affiliated with TWI, the Welding Institute.
That would be England.
Yeah, in Cambridge, and they had a program called the CSWIP program. Certification Scheme for Welding Inspection Personnel, and there were and these were member-based companies, so there would be companies like BP and Chevron and so on that would pay for a membership to those to those societies and or those organizations, and the oil companies knew about CSWIP for the work around the world, so they told EWI, said, you guys ought to bring CSWIP to this country. And so Carl Graff told one of his managers, he said, well, the right guy for the job is Dick Holdren, but he won't come.
He owns that company.
So another motorcycle friend of mine, Bill Bruce, knew me, and he kind of laid the foundation, and then I got invited for an interview, and at that time I was just kind of frustrated with the amount of effort I was putting into the organization, and the benefits were not that great at that time. So I went ahead and made the change, and went there. I worked there for 11 years, and then I left that and went to work again with another person. Or
another consulting company. Now you started a second one.
Yeah, and
that was in Columbus also.
Right, yeah, that was Applications Technologies. And
we'd stay in touch through all of this mess. You know?
Right. And then I came down.
Oh, I get to tell the story now. And so you show up here one day and sat down in my office unannounced and said, hey, I heard you need a welding engineer because Jordan had just left. And I said, yeah, I'm looking for one. And I said, who do you have? And you go, you. I said, you can't quit that company. You own it. And you said, I've done it before. And so you quit the second company that you owned.
Yep. So same payout.
Yeah, not much. Okay, but the rest of the story's fun. And so then fast forward to, there's a tragedy at Welding Consultants.
Yeah.
Bob passes away.
Yeah. Bill was involved.
Bill.
Yeah, he was involved in a car accident and was killed, and that was about 11 years ago, I think.
Right. And so what'd you tell me?
Well, I went and I went to his funeral and talked to his wife, and I said, what are you going to do? And she said, well, I'd like it to continue, but I can't do it. So I got you involved, and
we bought it.
Yeah.
I just think it's hilarious. We've gone full circle, and now you're back where you started in 81 or 2 or 3.
And I stole a guy was an engineer at Applications Technologies, Matt Brinkman.
Matt's a great guy. He is doing a great job up there. We've had him on the podcast.
Yeah, he's the best welding engineer I've ever learned or I've ever seen that started as a mechanical engineer.
Right, he's really an ME.
Yeah, and but he's doing great things, and
he's got a killer team up there right now. They are doing just amazing. They have really changed the way they make specimens. Now the Sharpies are all automatic, tinsels.
Yeah, and I always say that at welding, I started at Welding Consultants, and we did inspection, NDT, and then mechanical testing of welds.
And you still are.
Yeah, and I always say that there are very few mechanical testing organizations that know how to test welds. I mean, it's just a very special thing. And
you can distort the data if you do it wrong.
Yeah.
I can tell you that I've had Inconel specimens go to labs that come back and the hardness is wrong, and it's the way they prepared the specimen.
Yeah.
You got to understand this stuff.
Yeah, and just like on a Sharpie specimen, there's the first thing I ask a lab when I go, I said, when you prepare your specimens, do you control the depth of the notch or the amount of material that's remaining under the notch, which is really the part you're testing, which is really critical.
Right.
And using the available tolerances, that can be off by almost 10 thousandths. And so
that's a significant percentage.
And so I asked our guy that runs the CNC machines that does it. I said, which do you control? He said, I control the remaining thickness.
Yeah, he's a great kid.
Oh, he is.
He's doing great things. So I always tell people that in France they have a piece of platinum with 2 scratches on it, and that used to define the meter at one point. Now we're using wavelengths and stuff, but in Ohio we have the original defining undercut, right? Tell the story.
Well, when I was teaching the CWI program, Bill's famous saying was, "It's being a welding engineer is like being an anvil salesman. So, you can't carry metal samples around,
Right.
For examples. So we investigated, and we started making plastic replicas of welds.
Much lighter, portable.
Yep. And the first set that we made, I actually made the welds.
So you made the defects.
Yep. Yep. And and we're still selling that set.
Yeah, because you make a new mold around the part, and then you cast this resin, and
Right.
and this is what they conduct the CWI test with.
Right. We make the last 2 sets of replicas that AWS has used for both their training and their exams have been made at Welding Consultants. So
The standard for porosity, undercut, and underfill, and convexity.
yeah,
That's you.
yeah, and we, in fact, I'm in beginning of November. We're making up a new sample for the groove welds that were being used, because the groove weld sample we have is pretty limited. These are going to be, we're going to have both the root and the face of the weld shown on the replicas. Right now, all you got are weld beads on plate. So I'm going to be going to Hobart to work with them. They're going to actually make the welds, and then we'll make the replicas from those welds.
Outstanding. I just when we bought the place up there, that was an interesting part of the business that I'd never even heard of. But that makes perfect sense, because if you're taking the CWI exam in Omaha and he's taking the CWI exam in New York, you got to be looking at the same weld,
Yep.
and that's kind of hard to do had you not developed this weld replica technology.
Yeah, and we, I mean, there are other people making replicas now, but we still think we know how to do it. We have some secrets that we use, and make our samples very repeatable.
Yeah, you could pitch it. If you go to the website Welding Consultants LLC, you can buy these things online now.
And the hardest part about it is, what color is steel? We have played around with colors and everything, and it's
Silver, gray, black.
yeah. So
Oh, that's a pretty close match. This looks
Yeah.
like sandblasted steel.
Yeah.
I'm going for it.
yeah.
So this is a E70S-6 gas metal arc groove weld, and you're right. There is no root on the backside.
Right.
You're gonna fix that.
Yep.
What's next in your career? I mean, you got it. What's on your bucket list to do, or what's intriguing you nowadays? You don't seem to be retiring very well, because
No, I'm not ready to retire.
good.
I'm still enjoying what I do, and I'm still staying active on the code committees, and still feel like I'm a contributor. Just this thing that has come up here recently, where I dug into the codes, and
This is excellent.
have a lot of the procedures that, let me back up. When I used to qualify welding procedures back in Ohio, if I charged somebody $1,000 for a procedure, I thought I was really milking them.
And I've seen some procedures that now cost $200,000,
Wow.
depending on how much testing you want to do.
Yeah.
But keep going. So procedure qualifications is big bucks. That's
Yeah.
the bottom line here.
And but here in Houston, when we qualify procedures, customers come, they buy a piece of equipment, and we work with them and help them qualify their procedures. So when that piece of equipment shows up, they're ready to do production. And what I learned when I came here was that you don't just use Section 9, which is
ASME.
Yeah, ASME Section 9. Down here, you get to use API standards, and then if it's going into sour service, which everything offshore is sour service, you also have to satisfy NACE requirements. So it requires that you weld up a test coupon. You then have to subject it to post-weld heat treatments at 2 different times, so that it gives the user the ability to post-weld heat treat more than just the initial time.
And the reason for this is we have to have the post-weld heat treatment to get the heat-affected zone hardness down to what we want, but it degrades the base metal every time you do this post-weld stress relief, right?
Right.
Okay.
Yeah, and so when we'd write up these procedures, we'd write it up to say, it's a 4 hour and 8 hour are 2 pretty standard post-weld heat treat times. We've done some as long as 32 hours.
That allows you to rebuild or repair that part multiple times before you have to throw it away.
Right. And the way that we had always written it up was that every time that part comes back in and you restore the surface, or you build it up, if there's wastage and you've worn into the pressure boundary, you have to build that material back up, and then subject it to a post-weld heat treat again. Well, the way it's always been done is that they apply that 4-hour minimum. But I started thinking about it, started digging into the codes, and when I look in ASME Section 8, it basically says if you're working on parts that have already been post-weld heat treated, and if you're only applying the welding to the surface,
that's us. That's our world.
Yep. Then the holding time is based on that the surface or the thickness that you're applying the weld to. So
that's an hour per inch.
Yeah. So with this change, that 4 and 8 hour post-weld heat, those 4 and 8 hour post-weld heat treat times would allow you a cumulative 10 hours of post-weld heat treat. So you've got the 4 hours, that gives you 6 hours remaining. If you use the 4-hour minimum each time, you've got 1.5 cycles.
And the part's done.
And the part's done. But with this new approach that we've got backed up with the code, they've got 6 repair cycles after the initial 4 hour.
I love it. I mean, and to the listeners out there, if you're not welding people, this sounds like trivia or minutia, but this is huge. This could be millions of dollars savings.
Yeah.
A lot of parts could be saved. Less base metal degradation. This is great. And you're going to present this at our conference on Wednesday?
Yep.
So.
Yep. And I even got my presentation into Johnny.
Oh, good. I'm encouraged. I am really looking forward to seeing how industry receives this, because one, I'm surprised this hadn't dawned on anybody up until now, and two, their brains are going to explode when you tell them this. I'm really curious to see how they react.
I am too. I really am too. And I've invited some people to come listen. And
you think you can sell it? I mean, we don't have a dog in this fight, right? You know, it doesn't matter to us one way or the other, but it could save the industry millions of dollars.
Yeah. Oh, it's and like you say, just excessive post-weld heat treating degrades the material.
Right.
And so we're really being, we're using some engineering sense. So
I think it's brilliant.
Do you know the difference between a scientist and an engineer?
No, sir.
An engineer has a budget.
I see.
And that's what I went to the Material Science and Engineering Advisory Board meeting last week at Ohio State, and I used that line on them, and I told them, I said, we need to teach economics to our engineers, and I said especially welding engineers. They have to make decisions on a daily basis that is how they're going to accomplish what the codes require, but do it in a way where it's cost effective. So whether it's choosing the process, choosing the consumables that you're using, or simply changing the way that you apply the process, all those they end up being economic decisions. So, and using right materials so that they last longer. I was telling Abby this morning that when I was in grad school, I had a chance to take some metallurgy courses that weren't required, and you just didn't have time to take them. And some of those courses were one of the best series that by far the best metallurgy series I ever took was a series in mechanical metallurgy. And the first class was where you took physical metallurgy and related it to mechanical properties. So it would say, okay, if you end up with a microstructure like this is how it's going to perform in service. And
that's important.
Yeah, and it's basically what you're trying to show in procedure qualification. But one of the other courses I took was a course in corrosion engineering, and the professor was Dr. Mars G. Fontana, and the new material science lab in Columbus is called the Mars G. Fontana Labs. But he started out the class. He said, "Now, I'm gonna explain, or I'm gonna help you understand how to solve 90% of the corrosion issues that you'll ever encounter in industry." But he said, before I do that, I've got to explain some economics to you. And he goes up to the board and writes, "There ain't no free lunch."
Right.
And so that boils down to everything, really. So you got to pay for it now, or you pay for it later.
How thick is the zinc you're putting on your part? I've seen that. That's how they're more economical on galvanized materials now. They're making the zinc thinner, and so when people complain about it rusting sooner, the economics.
Yep.
Well, it's been fun, Dick. So what did I miss? What would you want to get in on this?
I think we've hit the high points. I'll think of something after we're off. But
well, we could do it again. Well, I tell you, Dick, I have had such a good career, and I count you among the very few people as my long-term mentors, and I appreciate it. And now you're working for me. That doesn't get any better.
Nope. And I go right back at you. It's been a real treat to work here at Arc. I see the enthusiasm throughout the company.
And all the youngsters that are getting into the system and learning, and we got the graybeards to teach them. Doesn't get any better.
I know. Yeah, and I get to work with Dave Hebel. Dave and I complement each other, I think.
Very different welding school, will turn out.
Yeah.
But they're people too.
Yeah, and we each have our strengths, but we are able to communicate well and get the job done. So,
well, thanks for all the support over the years, and thanks for coming on the podcast today.
Oh, I've enjoyed it.
All right, well, let's do it again sometime.
All right.
Thank you, sir.